A sound wave can travel from a source at P to a detector at R directly or by reflecting at Q. The angle between PR and PQ is 30 degrees, and the distance from P to R is D as shown. There is a phase difference of pi radians between the incident reflected wave at Q. Waves that reach R via Q are in phase, so that means a whole number multiple of 2 pi, with waves that reach R directly from P. So which expression gives the greatest wavelength of sound waves for which this is true? So what we need to get here is we need to get a phase difference. This would be 2 pi times the difference between the distances. So let's say the first path, take away the other path. So that will be this take away, something take away D. And then this is in phase, but there is a phase difference of pi at Q. So naturally this would equal 2 pi, 4 pi, or 0, 6 pi, 8 pi. But because there's an extra phase difference of pi here, what this means is that we're going to need a whole number, or odd number, multiple of pi. So this will be 2n minus 1 pi. So this is the phase difference due to the natural path difference. And this would be over lambda here on the left-hand side. So we need to work out the path difference over lambda times 2 pi. That will give us the phase difference, and then this should be a odd multiple of pi, so that when we get the extra phase difference of pi at Q, we get a solution where the two waves arrive in phase at R. So that's a logic for this. So we just need to work out how long this path is from P to R via Q. So we know this is 30, and so this must be 30 degrees. So this must be 60, which means this is also 60 because of incident and reflected rays. And so because that's 60 and 60, this must be an isosceles triangle, so this must be d over 2. So if we wanted to get this distance, which would also be the same as that distance because this is also d over 2, then what I'll need to do is d over 2 and then over the cosine of 30. So this is coming from CAH. So if we want to find the hypotenuse, we just do the adjacent divided by cosine of 30. So this is something that you should get very comfortable with doing. Naturally, most people can do the hypotenuse times cosine of the angle. So if you want to go from one of the sides to the hypotenuse, you need to be able to reverse that logic. So we've got d over 2 cos 30, which is d over 2 times root 3 over 2, which is just equal to d over root 3. Now there are two of these, so that's d over root 3 and another d over root 3. So we've got 2d over root 3. Rearranging this expression, we've got lambda is equal to 2 pi times d, and then this is 2 over root 3 minus 1, and then this is divided by 2n minus 1 pi. Now we wanted the greatest wavelength, so that means we want the denominator to be as small as possible. So what's the smallest odd number that we could have that's a whole odd number? That will be when the denominator is just pi. So we've got the pi's cancel and it's just a 1 pi on the bottom. So if we tidy up this expression, we'll get lambda equals 2d times 2 over root 3 minus 1. And as you can see, that answer is A. Hopefully this makes sense, but if you have any questions, please do let me know.